Artificial intelligence is a bit of a misnomer because it's not really intelligent in the sense that you would think of a human being being intelligent. So for example, I've got a 1-year-old son, and I taught him what a car was. Now, he's able to take that information and apply it and understand if he sees a real car out on the street or if he sees a car on television. He's able to put these things together. Artificial intelligence is not really able to do that. AI right now, where the technology stands, is it requires, hundreds, if not thousands or tens of thousands of examples of an entity, an object in healthcare, a disease, a diagnosis, to be able to identify that. The reason that we require so much manpower to train AI is that findings in healthcare and radiology are subtle, and in most cases, physicians or other healthcare staff are the experts in identifying those entities. And so a lot of human manpower is required to label or annotate cases, as we call it, in order to train an artificial intelligence algorithm. There's not just cancer versus no cancer. There are hundreds of potential diagnoses that can be attributed to a breast specimen. Breast cancer is subtle. So you have this entire mammogram, and the region in that image that represents the cancer is frequently less than 1 or 2% of those images. So you have this real needle in a haystack problem. So the manpower and the amount of data required to do that is much higher. So our data set here at Emory contains 110,000 patients. We have 350,000 exams over the last 9 years. It's 1.5 million images. We have breast imagers and oncologists that help us make sure that we structure this data appropriately, that our labels are clinically relevant, that they're valid. And so in the breast cancer space, it's a huge multidisciplinary, multi-institutional effort. We've got so many people involved because it is such a huge, technically and clinically challenging problem. It can be tedious going through this many images. I wouldn't say that we sit down and look at a set of 100 images and label them. What we really do is try to brainstorm a technique to label a whole batch of images. So we actually developed a second neural network to find these regions of interest on the mammograms and extract that patch of tissue so that we could feed the model, okay, there is an abnormality in this tissue here. Every step along the way, we try to make intelligent decisions and try to leverage all the techniques that we have in our armamentarium so that we have to do as little manual labor as possible for labeling this data. It's really kind of a roller coaster and multiple things kind of coming together. So your data set is here in the middle. This is your final product. And you have images coming from here, you have regions of interest coming from here, you have pathology data coming in, you have radiology data coming in, you have family history, social history, and you may have different teams of people, 1 or 2 people working on each of these things. And so everything is kind of happening. And as time goes on, the data gets cleaner and cleaner and cleaner until you kind of bring it together into this nice encapsulated, structured data set. And at that point, we can use that data to start building models and share with other teams and other groups and really kind of leverage it as much as possible.